coming back, modulo some sort of higher order stuff, right? Well, if I run this completely to convergence, then we know, right, the next iteration I'm going to replace QR with RQ, so when this thing converges, QR equals RQ, right? Because sort of nothing has happened in a fixed point. Does this argument make sense? Right? If it converges, then QR is going to equal RQ. Okay. Well, then what? Well, okay. So this is not 100% clear, but what we can see is a few things. So we have a basis for the column space of A, right, which is this Q thing. We have an R, which is a way to combine that basis to get A again. And let's think about what this does. So let me get my notes here. Right. Okay. So the eigenvalues of R, as you showed on your homework last time, right? The eigenvalues of R are what? Just the diagonal values of R. R is an upper triangular matrix. Yeah? So in particular, what do we know? Well, we know that, well, if the eigenvalues of R are a diagonal matrix, then what are the eigenvalues of A infinity? Or are the diagonal of R, rather? What is the spectrum of A infinity? Well, it's also the same as the eigenvalues of R. We know that because of this RQ expression, right? Because somehow post-multiplying by an orthogonal matrix doesn't change your eigenvalues if you think about it. Right? Why is that? Well, remember that one of the ways you can do eigenvector stuff is by thinking about this Rayleigh quotient. Right? The Rayleigh quotient is nothing more than sort of looking at the scaling factors, right? But if Q is a rotation, right, then Q doesn't sort of scale things in any particular way. I know this is fuzzy, but unfortunately we're low on time, so probably on Monday we'll go back and argue this for real. But anyway, so QR is RQ, the eigenvalues of R are still the diagonal of R, right? And that means that QR and RQ have the same eigenvalues because they're equal. And in fact, they all have the same eigenvalues of A. So maybe we'll stop with that calculation, and we'll show that really quick, which is, let's say, well, in fact, actually, even easier. Why does A infinity have the same eigenvalues as A1? Well, remember, how did I get to A infinity? Well, I got so by doing this QR RQ factorization, but all that was really doing is conjugating A by a bunch of different Q's. Right? We know that each of these conjugation steps doesn't change the eigenvalues. Right? So the eigenvalues of A infinity have got to be the same as the eigenvalues of A. And if it turns out, which we'll prove next time, that R is diagonal, then it's very easy to see that the eigenvalues of this thing have to be just the diagonal values of R. So that's going to be our proof sketch, and next time we're going to go through the iterations of this thing and actually prove that this converges to the eigenvalues and eigenvectors of A. But I think actually we'll stop here for today because it's a little bit involved. Yeah. So anyway, so your homework went out today. You have a homework due tonight at midnight. Hopefully today's homework is easier. Next week, next Monday, a homework will not go out because the following Monday, Wednesday, I forget, is your midterm. Okay? So yeah, the next homework should be easier. I'm trying. And even if it's not, just come and get my help. Please come talk, post on Piazza. A lot of you guys are posting privately on Piazza. Don't do that. If you have a generic question, then ask it publicly so I don't have to answer it 100 times. Cool? Cool. Alright, so if somebody can hit the button on the camera, we'll call it a day. And on Monday we'll approve